How are we doing today? I'm going to be doing notes a little bit differently today because I want to get through some practice, and with me not being able to write on my computer screen, we're going to go this way with it. I think I can write with my pen if you guys can see it. So there's no bell ringer today. Just letting you know, test. This is the last day of new notes before the end of the unit, so our test will be next Wednesday. So make sure you're mentally prepared for that. Okay, so the first thing we're going to do is we're going to talk about, we talked about the 5 reaction types last class. We talked about synthesis, decomposition, single replacement, double replacement, and combustion reactions. And I know I kind of cut it off at the end, but I wanted to get into, today we're going to do what we call predict the products, where I'm going to give you the reactants or a type of reaction and have you try to kind of write them out. So we'll start off kind of simple here. We'll start off with phosphoric acid. Well, now normally I could give you the name and just ask you to write it, but I'll give you the formula for it as well. So we're going to react phosphoric acid with potassium hydroxide. So H3PO4 and KOH. So first thing you got to do is figure out what type of reaction it could be. It cannot be decomposition because it's got two reactants, so it can't be that. It can't be single replacement because you have two compounds. A single replacement reaction only occurs with an element in a compound. All right, so now we're left with combustion. It can't be combustion because it doesn't have an organic compound, a compound with carbon or oxygen as the other thing. So you're down to, this can either be a synthesis reaction or a double replacement reaction. Okay, so I'm going to tell you that this is going to be a double replacement reaction. So at this point, you can write the products. Now, but one thing we do have to do is we do have to check to see if the reaction will occur. What we would do to see if the reaction would occur is we have to look on reference table F to see if the compounds are soluble or not. If they're insoluble, any of the reactants are insoluble, the double replacement reaction won't occur. So our first compound is H3PO4. So H3PO4. So phosphates are generally insoluble, except when combined with, it gets cut off on here with a group 1 ion. And since hydrogen is considered a group 1 ion, then this one is a soluble compound. So the H3PO4 is soluble, so that works. And then we got KOH. All right, hydroxides are generally insoluble. And then you have over here, Ks are group 1 ions, so they're here. So this trumps this, and if you look, the hydroxide are generally insoluble except when combined with a group 1. So it's going to be soluble. So both these are soluble, so that means they're both going to react, so we can get products here. So what we have to do is we have to see where the compound's going to split, so to speak. All right, so you got H3, you got PO4, and this is where, you know, if you can't remember these things, I would keep your table E kind of handy dandy for you so you can look at it and see. But we've got H3PO4 is going to split into PO4 because PO4 is a polyatomic ion right here. And then KOH, there's no KO on here, but there is an OH. All right, so you're going to get a compound. So this is going to split here and here. And if it has parentheses on it, it makes life easier for you. Okay, so now we have to make a compound with hydrogen and OH. So I'm going to kind of do a little scrap paper under here. So hydrogen's got a +1 oxidation number. OH has got a -1 oxidation number. Crisscross jump. All right, and you get HOH as one of the products. You can also write that as H2O. So that's product 1 or product 2. It does not matter. And then the other compound is going to be with what's left. So we have the K left and we have the PO4 left. So we have to put the K1 first because the K is a positive ion. So K is a +1. And then PO4, if we look down here on our table E, PO4 is a -3 ion. So we go PO4 -3. So we look here. So now this is going to crisscross. All right, so you're going to end up with K3 and then parentheses PO4. Okay. What we have to do now is we do have to balance it. All right, so we have to check to make sure it's balanced. If it's not balanced, we have to balance it. So we have to uphold the law of conservation of matter. All right, so if we look here, I'm going to do phosphorus is first. So P, we have 1 P. We have 1 P, we're balanced. Ks, you have 1 K here, you have 3 Ks here. So to balance the Ks, I'm going to put a 3 over here. Now we go to either hydrogens or oxygens. It really doesn't matter which one you go at first. I'm going to go at hydrogens because the hydrogens are in 3 spots and the oxygens are in all 4 spots. It might be helpful, it might not. I don't know. So if I look here, I have 2. So I can only get multiples of 2 hydrogens over here. Okay. Over here, I have 3 hydrogens here and I have 3 hydrogens here for a total of 6. So since I have 2 already right here, to get this to 6, I have to put a 3 as a coefficient. All right, because it's 3 times 2, which is 6, and then that makes our hydrogens equal on both sides. Now let's check our oxygens. So here for oxygens, I've got 4, and I've got 3 here for a total of 7 oxygens. Here I've got 3 oxygens here, and 4 here for a total of 7 oxygens. So my coefficients are as such. You have a 1 in front of here, a 3, and a 1. All right, that's a double replacement reaction. Okay, we're going to do another one. Actually, this one I'm going to have you, I'm just going to roll through it, but on the Edpuzzle, I will probably stop it. So we got potassium phosphate. We're going to stick with phosphate here. All right, and aluminum chloride. Okay, and these are going to react or not react. Remember, how do we tell if they react? You're going to look at table F. All right, you look at table F. So we've got potassium phosphate. All right, potassium is a group 1 ion, so that one's definitely going to be soluble, so we don't even have to look at the phosphate. And aluminum chloride, all right, aluminum's not on here, but chlorides are. All right, and aluminum's not an exception, so those are both soluble, so this reaction will occur, so we're good. All right, now we have to crisscross jump jump. Well, before we can even do that, we have to figure out what the compound splits. All right, this one's nice because it's only got 2 elements, so it's going to split between the Al and the Cl. And then this compound, hopefully you recognize, is similar to this one up here, so the PO4 is going to split off from the K. All right, so in this case here, the K, the positive ion, is going to make a compound with a negative ion here. And then the aluminum is going to make a compound with a negative ion there. So which one we want to make first, completely up to you, doesn't matter. You cannot just throw the elements together. You do have to crisscross. So K, I'm just going to use this as my scrap paper, K plus 1. I'm not going to take the time to look up on the periodic table. You can have yours available to you. Chlorine, if you look it up on the periodic table, it's got a negative 1. Crisscross jump jump. So you get KCl as the formula of the first compound, or the first compound we're going to do. It doesn't have to be the first one. All right, and now we got to have a compound between aluminum and phosphate. So aluminum has to go first because it's a positive ion. If you look up on the periodic table, aluminum has a +3 oxidation number. And then the phosphate, all right, so phosphates you might not be as familiar with, but we just look on table A, phosphate has a -3 oxidation number. So when we crisscross jump jump, you're going to get Al3PO4 3. But since both the subscripts are 3, they can both be divided by 3, so they can both be reduced. So the formula of your compound is AlPO4. All right, whether you put parentheses or not is up to you. I try to make sure that you guys do write parentheses around these. It makes it easier to see some things. Actually, it makes it easier to balance, I think. But anyways, so now we have to balance this thing. Can it be balanced? So you got 3 potassiums here, you got 1 potassium here. So we have to put 3 potassiums there. All right, and then we've got to look at, let's look at phosphoruses, I guess. All right, you've got 1 phosphorus here, you got 1 phosphorus there, we're good. All right, aluminums, you've got 1 and 1, we're good. Chlorines, we got 3 here, we got 3 here. And then oxygens, you got 4 and 4. So it's already balanced. So that one was a fairly simple one to balance. All right, let's try the next one. All right, so we've got HCl and zinc carbonate. Okay, I'll write it with parentheses to make life easier for us. Okay, now because it looks like it's 2 compounds, it's probably leaning towards double replacement. So let's look to see if they're soluble or not, because they both have to be soluble. HCl, all right, all chlorine compounds are soluble except with those things. H is not an exception. H is also a group 1 ion, so HCl is definitely soluble. ZnCO3, carbonates generally are insoluble. The exceptions are with a group 1 ion and ammonium. Zinc is not a group 1 ion. Zinc is over in the transition metals. Therefore, this one is insoluble. So what that means is no reaction. All right, so you're right, no reaction. RXN is an abbreviation for comments for reaction, so we don't write out the whole word. So you don't have to do anything other than that. You're good, you're done, okay? All right, so now I'm gonna try to mix them up a little bit in the types of reactions that we're gonna do. All right, let's do, so these were all double replacements, okay? So now we're gonna go into this one, C6H12. All right, which is hexane, if you know what hexane is. All right, produce something. Okay, so we have our 5 reaction types. We have synthesis, we have decomposition, we have combustion, we have single replacement, we have double replacement. All right, and we can abbreviate these all like this. I'm just going to write it up here. Synthesis, decomposition, combustion, single replacement, double replacement. So we have those 5 choices. All right, these reactions are all double replacement. I'm just going to write it here. All right, so this reaction right here, it can't be decomposition because it's got 2 reactants. All right. Possibly could be single replacement because it's got an element in a compound. Can't be double replacement because it doesn't have 2 compounds. Synthesis, it's hard to tell synthesis, but generally for us at our level, it's just going to be 2 elements combined 95% of the time. Okay, so and it could be combustion too. Remember, combustion is reactant is oxygen and an organic compound. Because this has carbon in it, that is an organic compound. This is a combustion reaction. All right, and you have to remember what are the products of all combustion reactions? All combustion reactions have this same product. They produce carbon dioxide and they produce water. Okay, and if you want to go water and carbon dioxide or carbon dioxide and water, it's completely up to you. Now what we have to do is we have to balance it. So we start off with 6 carbons, we finish with 1, so we have to make this a 6. All right. Hydrogens, we start off with 12, we finish with 2. So we got to get this to 12, so we put a 6 here. All right, then oxygens, we start off with 2. Now over here we have 12 oxygens, and we have 6 oxygens there for a total of 18 oxygens. So we got to get this to 18 oxygens. To balance that, we got to put a 9 there. And this is a combustion reaction. I'm going to abbreviate with a C. Okay, so I get that these are hard, but you do have to kind of work your way through it. All right, let's do this one. Iron, 2 carbonate. And then that. So the nice thing about this is easy to identify what type of reaction it is because it's only got one reactant, and it's got to be decomposition. All right, it's going to decompose. This is a harder one to do the decomposition for, though. All right, because anytime you have carbonate, and this is something you'll learn the farther you get into chemistry, all right, that's going to produce carbon dioxide. All right, carbonate, like if carbon dioxide comes into contact with the water, it will make this CO3 ion. So you're going to end up with iron and carbon dioxide. Now we have to balance this thing. All right, so 1 carbon, 1 carbon, 1 iron, 1 iron, but we have 3 oxygens and 2 oxygens. So we got to get, actually, do I want to use this one? Well, we'll try it, but I'm trying to think ahead. 3 and 2. Yeah, we're never going to get those carbons balanced. Let me try a different decomposition reaction. Let's do potassium bromide. Make potassium bromide. We'll make it easier. We'll do this one instead. So decomposition reaction. What's potassium bromine going to decompose into? You got potassium and you've got bromine. The thing you got to remember though is bromine is a diatomic element, so it's got to be written as a Br2. Okay, now we have to balance it. So 2 bromines, 1 bromine, so we got to put a 2 here. We now change into potassium, so we put a 2 there. So that's our decomposition reaction. Sorry about that first one. I tried to do it off the top of my head, and I picked a bad one. All right, let's try this one. Zinc and copper sulfur, copper 2 sulfur. Okay. So you have this reaction right here. So you have an element and a compound. All right, element and compound has to be a single replacement reaction. Single replacement reactions, you have to remember to look on this table J. Table J is right here. Remember, for this reaction to occur, just like double replacement reactions, you have to check to see if they'll occur. Double replacement, you look for solubility. For single replacement reactions, this element has to be more reactive than the element that's going to kick out of the compound. So we have to look here. In zinc, being a positive ion is going to can only kick out the copper. So we look down here. We got to find zinc, and then we got to find copper. Copper is way down here. So zinc is definitely more reactive than copper, so this reaction will occur. So the zinc's going to kick out the copper. As a result, copper is going to be by itself. Now we have the formula of the compound between zinc and sulfate. So I'm just flipping back to my table E. I'm trying to use the reference table just like you guys would use. All right, so zinc, if you look on your reference table or your periodic table, is a +2 ion. Sulfate is one that you look up all the time. Sulfate is a -2 ion. SO4, -2, crisscross, jump, jump. All right, you get Zn2SO42. Those 2's will cancel out. You end up with ZnSO4. Balancing this one. So one zinc, one copper, one sulfur, 4 oxygen, 4 oxygens. It's already balanced. So that worked out really well for us. Okay. Last one. I think again, I'm going to switch it down in here. Barium chloride reacts with sulfuric acid. All right, or can react with both sulfuric acid. So this is 2 compounds. It's going to be double replacement. So I can put a DR here. Double replacement. We have to check to see if things are soluble or not. All right, so we have barium chloride. So chloride is a halide. Barium's not an exception. So barium chloride is definitely soluble. Sulfuric acid, H2SO4. All right, SO4 is soluble because it's on this side. Hydrogen's not an exception, so this one's soluble. Okay, so once again, the positive ion here is going to make a compound with a negative ion there. Then the positive ion here is going to make a compound with a negative ion there. So whichever one we want to do first, completely up to you. All right, so we already have the sulfate ion right here, so I'm just going to copy this down. And the sulfate's going to make a compound with the barium. So barium, and when we look up barium on the periodic table, barium's a +2 ion. So crisscross jump jump would be Ba2SO42, which becomes BaSO4. Plus, all right, now we've got hydrogen and chlorine. Hydrogen is a +1. Hopefully you know that. Chlorine's a group 17. Group 17s are -1. Crisscross jump jump, you get HCl. Okay, is this thing balanced? Bariums are 1 to 1. Chlorines, you have 2, you have 1. So you got to put a 2 here. Sulfurs currently are balanced. Hydrogens are balanced, 2 and 2. Oxygens are balanced, 4 and 4. So we are done. Okay, so that's probably one of the most challenging things we're going to do up until this point in time in chemistry, is to be able to look at, whether it's given in words or formulas like this, and figuring out what type of reaction it is, and then writing the products and then balancing it. So it's quite a big step in there to do this. I will give you some sheet to practice this, and then we'll take questions in class. All right.